Hello guys, my name is Arun and welcome to my channel. This series is a series of tutorials on Advanced Fortran programming. Now in this tutorial, we will be looking at one interesting concept and a concept that will be very used and very important for data handling and for grouping data and processing them as a one unit. Okay, this kind of this unit is actually called, this type is actually, what we are going to do today is that we'll be looking at one important concept called as derived data types. Now these derived data types are exactly more or less similar to the structures in C and C++. Okay, now what is a derived data type is that it is kind of similar to arrays, but at the same time it's kind of similar to a variable, wherein wherein you're defining a new kind of a data type, wherein each derived data is actually a composite collection of multiple basic data types. See, in the Fortran, okay, the basic fundamental data types are integers, real numbers, uh, logicals, complex numbers, and so on. Okay, but and even characters, so on. But if you want to make a composite collection of these, okay, and if you composite collection of these is a little difficult. If you want to have a homogeneous collection of these values, like an integers, characters, and real numbers and logical numbers and all, you have the arrays. Okay, and you have the arrays. Okay, but if you want to combine an integer, a float, a character, and several others together as a single variable and operate all of these values separately inside, then Fortran does not have any feature to define a heterogeneous variable like that. But that kind of a feature can be implemented. That kind of feature can be implemented nicely using this type variable, using this type definition, or using derived data types. Okay, now enough of me talking of that. I'll walk you guys through. Okay, what see, look at this line over here. Okay, I'm using this keyword type to define the name of a derived data type. Now this derived data type is called a stud. Okay, and inside this derived data type I'm able to incorporate two variables inside, and each of them are different in nature. One is an integer named id underscore n. Another data type is actually a character array of 20 units long. Okay, now in a normal array or a normal Fortran, if we were to combine these two to form a single entity in the form of an array, it's not possible. But using this type attribute over here, we can Fortran allows you to define a new data type. Okay, big new data type wherein you can combine and merge integers and characters here. Not only integers and characters, you can also include real numbers, complex numbers, logical numbers, even arrays, even integer arrays, complex arrays, logical arrays, whatnot. You can combine those and operate them as a separate entity. Now where does this kind of arrangement is used? I'll give an example. Suppose in a class of say 50 people. Okay, there are like 50 students in a class, and now each student has certain variable, has certain data with them, like his name. Yeah, to start with his name, then he might have a roll number or some kind of an identity number. Okay, then he might then maybe his age, maybe his sex, maybe he may be a boy or a girl. That gender differentiation variable, the marks he might have scored in 4 or 5 of the subjects. uh, let's see what else. Yeah, his average in the class, is rank and all. So if you guys notice, for each and every student you have like seven, you can put like 7 or 8 variables for each and every student. Now there are 50 students, and if like 8 variables for each student, there will be like 400 odd variables to define and make. Now won't that be hard? Okay, but if you define that in this kind of a if you kind of define this in type variable like this, that definition becomes just quite immensely easy. Okay, all you have to do is just define a type for a particular student. Say just I'm just including two things over here, like an id is id number, and then his name. Simple as that. Okay, and if you guys want, you can include the other subject names, other subjects, as gender like male or female, as age if you want, uh, like what's his average, what's his rank in the class, what his or her rank in the class, so on and so forth. You can just add so many variables. Now because of this kind of feature, you're defining eight or seven variables under one type definition, and you can use that type definition to define as many students as you want, and without losing it, without having the tiresome or cumbersome need to repeat it again and repeat the variable generation again and again and again. Okay, now this is how the type goes. Now if you want to access, okay, I'll come to the access point later. Now what I did is that I defined some character arrays, namely prof underscore name 1, stud underscore name 1. This is for this is a professor name, this is a student name. Okay, like that I've defined 3 professor names and 3 student names. And if similarly I've using integers, I've defined 3 professor IDs and 3 student IDs. Okay, now with this type being defined like this, I can create multiple student names, like multiple students like this. Now this is the type. This stud is actually the derived data type for the student. Okay, and if I were to create a new variable for, if I were to create a certain a separate set of data for say one student, all I can do is that I just have to write type within bracket stud, and define a variable called a stud1. Now this stud1 is actually a derived variable, which has the id number and name 1 to it. Now if I wanted to define the attributes id number and name for another student, let's say, all I have to do is that I just have to type stud3. Simple as that. Now stud3 will hold the variables, will hold the values for another student. Suppose if you want this to be defined like an array, let's say, all you have to do is that give the type, you write the type over here, type stud, and then give it as an array. Simple as that. Now if this array is actually of 2 value. Okay, suppose if I were to register this as 50. Okay, now this stud2 is a single variable. Okay, and each of its 50 variables will be a derived variable of type stud, and each of those 50 stud variables, 50 stud variables, have 2 of these variables, integer id number and name. So if you guys notice, if this way it's absolutely easy to monitor or collect or assign or use the data for each and every student in a class using this way. Now what I defined is that I just define this to be 2 for simplicity, and here I just setting the number of variables here to be just 2. Okay, now we look at an example now. Okay, ignore this professor type for now. Okay, we'll come to that later. Okay, now what I have done here is that, okay, is like this. Now this derived variable stud1 has 2 variables in it, id underscore number, id underscore now, which is the id number, and the name. Okay, and if I want to access that, and I want to use it to manipulate or use it just like another variable, what I have to do is I just have to type like this. I have to use the percentage sign to get the value. So what I have to do is that I just have to type the derived data type name, put a percentage sign, and say the variable inside this derived data type. Okay, So if I were to write like this, stud1 percentage id underscore no, what does it mean is that we are accessing the variable id underscore num id number, variable id number in this derived data type stud1. Okay, and we are accessing that, and we are putting this to be equal to stud underscore id1. So what happens is that this id value inside this data data type stud1 will be set to 31. Similarly, okay, if the stud variable is actually defined, if this derived data type is defined like an array, okay, I can access the variable value for each and every stud value like this. Now stud2 of 1 accesses the first stud type derived element in dimension 2, first stud type derived type in this stud2, and assigns its id number to stud underscore id2. Stud underscore id2 is over here, and this will assign the second this statement over here, because of this 2 over here, will assign the second value. We'll call the second stud derived data type in this stud2 array, stud2 type array. Okay, and in that it will set the id number to be the value stud underscore id3. Okay, similarly I can set the name of the corresponding stud values over here using this statement over here. Suppose if I want to use them somewhere for some manipulation or some calculation, I can just, instead of this single variable over here, I can just use this. Now this way, if you want to access loops or something of the loops, or if you want to do some nested loops or something of that sort, this kind of derived data type definition is very very useful. And what I'm doing here is that I'm printing the student IDs over here, and I'm printing the student names over here. Okay, now that being said, now let's look at this. Hope you guys okay, before I go on to the next one, hope you guys understood up to here. Okay, now let's go on to the second part of it, second part of this thing, derived data type tutorial. Suppose if I want to pass this type, derived data type, to some other function or a subroutine, let's say, then it's not that easy. If I were to define this type within a program like this, then all the procedures like the functions and subroutines that are defined, okay, within the program, they can access it easily. But if you want this kind of derived data type to be available to other functions and subroutines, okay, then there's only one simple way to do that, and that is using the modules. Now what I have here is that I just have a module called as Deri. Okay, it starts here and ends here, and inside this I use this implicit none, and I use the save command, okay, to define a new derived data type called as prof. This, by intuition, you guys might have figured out, this will store the professor's ID number and the professor's name. Suppose suppose you have a college or a school or any higher education place, or even some research institute, let's say, and you have a lot of professors working over there. If you want to store the ID number, identity number, or ID number and their name or something of that sort, this prof type can be used over there. Okay, I'm just limiting to the variables to be 2, but you can, if you want, you can add so many other variables of your choice. It's just up to you. Now because I define this type or professor derived type over here, and I use the save keyword to make it available, to make this type available to everybody. Now what I have to do is that if I want to use this professor derived data type in my function or in my program, all I have to do is this, that I have to use this module inside my program, and if I use this data type prof will be available. Now since this is available here in my program, I can define I can define a prof1 derived variable based of type prof, okay, and using the same I define define a 2D define an array, a one-dimensional array of the prof2 types, okay, just like how we did in the for the student, okay, like that I can do that. And I just like the student, I can assign assign the ID numbers using the values over here, and the names just like using the values over here, just like how we did for student. And to print all this, okay, I'm not I mean, since we saw this working over here, okay, I thought a little better to give you guys an example of how to get these jobs printed in uh, in a subroutine. Okay, so what I do is I just call the subroutine deri underscore print, and this deri underscore print is nothing but it's nothing, it just prints these 6 statements with respect to the professor, and that's it. And what this does is that this again uses this this module over here. Now if I were to comment this out, if I just were to pass this, okay, compile this, it will throw an error. Okay, so this way, if you guys notice, it is not possible to pass the derived data type directly into a function or a subroutine, because the functions and subroutines, they know by default that they can handle normal data types like real, real, integer, complex, and all. Okay, but they do not know, but functions and both functions and subroutines, they do not know how to handle derived data types. For if you want them to know as to how to handle it, then there is only this is the only possibility. You have to go for modules and use this save command. Suppose if I were to comment the save command and run this, compile, build, and run this, sometimes they will work. They will work, okay, but the save command is used to set some default values. If you want to set some default values, okay, now what I do is that I just pass this value to be 1, the value to be 2, and if I pass this value to be professor x, okay, professor x, okay. Now if I were to save this, okay, compile, build, and run this, you don't see any change over here. Because the way this program is written, these values get modified. Okay, now what I do is that I call this statement again. I call this statement after the definition. After this definition, if I were to compile, build, and run this, if you guys notice, when I call these values initially, okay, they already have values set to them, 2 and professor x. So when this subroutine call has been made, it prints the student ID to professor ID to be 2, and the forget about this. I'm sorry, it's just a typo. I should have changed this to prof1, prof2, but anyway, that doesn't matter. What it matters here is the values over here. Okay, it just sets the values to be 2, and professor x, just like what we mentioned over here. So in this way, okay, even if your derived data types do not have a value, you can use the save command to fix a default value to them, so that you can access them later. And if you you can access them later. And suppose if you were to reassign some values like these, like how we did over here, those values get overwritten, so nothing to worry about. Okay, that's the reason why even without any values being defined over, but if I were to, I mean, this is the reason why even without any values being defined over here on the top, if I just declaring but not assigning any, okay, this function prints the value nicely. But if I were to remove the save function, okay, if I were to remove the save function, if I were to compile, build, and run this, uh, fortunately it works. Fortunately it works. Sometimes they may not work in some compilers. Fortunately in my compiler it's kind of working. I have absolutely no idea as to how this works. Okay, let me remove all the star.o and star.exe if there are any. Okay, and derived. Okay, and I remove this star.mod file over here. Okay, star.mod file over here. If I were to compile this and run this, and I remove the save command over here. Okay, I remove the save command over here. If I were to compile this in one shot, compile and build this in one shot using this command. Sorry, I think this should be sorry, I forgot. What am I typing? Fortran star.f f95. Okay, I'll get this file a.out. If I were to compile this a.out, surprisingly it prints. Maybe in some compilers, if you don't put the save command, then this derived data type may not be available. Okay, but this is the thing. If you put the save command, okay, if you were to change this data type value in somewhere in if you were to change this data type, the inbuilt data type of this type prof in some other function or some other subroutine, the inbuilt data type value some other function or some other subroutine, then that gets reflected in all the programs and all the subroutines which uses this data type. So that's the reason why save is used. Sometimes even if you don't, sometimes it's not at all required, but it's kind of required, especially if you have values like this, and if you want to make changes to the basic data type itself to everywhere else. Okay, now this kind of thing can be used in several places, especially for data handling and stuff. Data handling, and if you want to work with the data structures kind of job, if you're working with that kind of a job, or if you have that kind of a process or work to do, and if they have that kind of number crunching stuff or data handling stuff to do, okay, this the derived data types will be very useful on that regard. All right. Hope you guys understood this example. I did my best to explain this. Okay. If you guys notice, this has a lot of advantageous features, and which can be used quite nicely for several applications. So all you need is just a proper application, and if you have a proper application, you guys can do a lot of stuff over here, lot of stuff using these. Okay, thank you guys for watching, and I'll see you guys next tutorial. Take care. Bye.